we're talking about sequences, sequences are basically just a list of numbers that follow a pattern or rule. Your terms are each number in a sequence. And remember that we list those as like a sub 1 is our first term, a sub 2 is our second term, and so forth. And then a sub n is going to be the general term. Given, so like a sub n again is our general term, and basically this is the rule that our numbers are going to follow. So if I want to find the different terms in it, so like on this one we're looking for the first 4, so a sub 1, a sub 2, a sub 3, and a sub 4, we just plug in our 1, 2, 3, 4 into our in for our equation or rule, and that will give us the term. So if we plug in 1, what do we get? Just 1. And then next we can plug in 2, and we're going to get 4. And then we're going to plug in 3, and we get 7. And then lastly we plug in 4, and we get 10. Is there another pattern that my numbers are following?
Adding 3.
Yeah, we're adding 3 each time. Okay. So sometimes we can think about it in terms of like the rule itself, or sometimes we can think about it in terms of like reference to each other, like what's my pattern that's happening there. So this was a linear type of equation. What's our next type of equation? It's an exponential. Luckily we've had some practice with those at this point. So what is -1 to the first power? -1. So then 3 plus -1 gives us 2. But when I raise -1 to the second power, what do we get? +1, so 1 plus 3 gives us 4. So then is it going to change much depending on what my exponent is? No. If I put in an odd exponent, then this will always be -1, so overall we will get 2. And if I put in an even exponent, it's always going to be positive, so we will get 4. So this one is what we would call an alternating series, or sorry, sequence, and so it just goes back and forth between 2 and 4. What questions do we have there? Now there are a few sequences that are like special. One of them is the arithmetic, the other is the geometric. Those are the two that we are going to focus on. There are other ones out there that are also like special ones, like the Fibonacci sequence and like our alternating sequences. But we're mostly going to focus on arithmetic and geometric. So our arithmetic sequence is a sequence where a constant is added to each term to get the next term. So like that first example we did, we were adding 3 each time. So that would have been an arithmetic sequence because we were adding 3. Now, you don't really have to like, a lot of words up there. Basically, the biggest thing that you need to take away from this part on the bottom is that this is going to be our formula for our arithmetic sequence. And the common difference is just that constant that I was talking about. And the reason they call it the common difference, even though we're adding each time, is because if I want to figure out what I'm adding each time, we would subtract 2 of our terms to figure out what we added. So a sub 1, again, remember, that means that we are starting with our first term. N just represents the term that we're wanting to find, and our D is that constant or common difference. Now, for your test over these couple of sections, I will be giving you all of your equations, okay, because there's quite a few of them, and really more what I want you to take away is like how to use each of the equations, not that you need to memorize all of the equations. Also, like, this is a shorter section or unit, so we don't have a ton of time. We won't be there. However, you still want to write it down. You're gonna have to use those on your homework, but you do not have to have these like memorized. You do need to have memorized like what each of these mean, right? The A and the A sub 1, the N, and the D. But you don't have to memorize the whole thing. Alright, so this one tells us that we have an arithmetic sequence. So like there's 2 different ways that we can see a sequence. One of them is the A sub n stuff, and the other, we said that a sequence is just a list of numbers. So they can also just give it to us as a list. And so this one asks us to find the 12th term. Now, one way that we could do this is, if we look at that, what is our D value, or like what we're adding each time? 7. So if you really wanted to, this is the 4th term. You could keep adding 7 until you get to the 12th term. All right. Which for 12 wouldn't be that bad, but like if I asked you for like the 45th term, right? We don't really want to do that. So we're gonna practice using our formula. So we're just using this A sub n formula that we had on the previous page. And then we're just plugging in the information that it gives us. So we are wanting the 12th term, so that goes in for our n. Our sequence started at 9. Again, we want the 12th term, and we said that our common difference was 7. So we get 11 times 7. Which gives us 77, and then we're adding 9, so we get 86. So that would be our answer. What questions do we have there? None of the sequence and series stuff is like particularly like difficult. It's just knowing which thing to plug in where. Like that's really the hardest part. So there's kind of a lot of variables, and so you have to know like how to find each of them. Okay, let's look at another one. So this one says write the equation for the nth term of the arithmetic sequence. So this time it's not wanting us to find a particular A sub 4 or 12 or whatever. It's wanting us just to find the general formula. So we're still just using that a sub n equals a sub 1 plus n minus 1 times d. So what is our first term this time? This time, we're not plugging anything in for n, because we're wanting a general formula. So like n is acting like our variable, kind of like normally we have x's. This time we're going to have n's instead. But we do need to plug something in for d. So what are we adding each time? Negative, what? 18. Mm-hmm. So we do want to make it negative because we are going down, right? And we said that our arithmetic sequence is adding something each time. So technically we are subtracting something each time, or adding a negative. So our d value is going to be negative. But we do want to clean this up a little bit. We don't tend to write our sequences that way. So we're going to distribute our negative 18. And then just combine our like terms. So we get a sub n equals negative 18n plus 23. And then from there, you can use that formula to find any term that you wanted. Yeah. So far, so good? Okay. Alright, next up, very related to our sequences are our series. And basically, a series is just the sum of the terms of a sequence. So instead of like the commas, you know, we had like 3, 7, whatever. Now we're going to have addition signs because we are adding each of those things all up together. And we have 2 formulas that help us find the sums for arithmetic sequences. So again, I will give these to you, but you might go ahead and write them down just so you have them for reference. So our first one is s sub n equals n times a sub 1 plus a sub n divided by 2. I will say, like, this top one is the one that we use the most often. And then on the bottom one is s sub n equals n divided by 2 times 2 times a sub 1 plus n minus 1 times d. Let's look at an example. So this says find the sum of 12 plus 19 plus 26 plus ... all the way until I get to 180. So this time, what is our d value? What are we adding each time? Seven. Okay. What's our a sub 1? What's our a sub n? Or the last one that we're going to? 180. Okay. Now, the problem that we have right now, okay, is that we have our a sub 1, we have our a sub n, right? So we can plug into the start formula, but we don't know how many terms are in between 26 and 180, right? That's what that dot 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 means, is that it follows the same pattern, but I don't know what term that is. Does that make sense? And we need that, we need to know what n is in order to plug into our formula. Yes, no, maybe? So, we're first gonna have to use that a sub 1 plus n minus 1 times d formula to figure out what our n is. So, because we know a sub n, we already found that, it's 180. We also said that we know that a sub 1 is 12, and our d value is 7. So, by using our other formula, we can solve for n, and then we can find our sum.
Is 180 the n, or whatever, because it's like the last one?
Correct, yeah. So a sub n represents the one that you're going to.
Okay.
Right. So then what do we want to do? Sure. And then
Combine my terms.
12 plus 7 gives us
-7. Oh, -7.
oh sorry, 12 minus 7 gives us
Which one was that? 5.
5. There you go. Okay, and then okay, so we get 175 and divide by 7, so we get n equals
25.
25. Which we should get a whole number, okay? Because we don't ever find the like 2.5 term, right? I find the first term, the second term, the third term, and so forth. So if I get a weird number here, two things happen. Either one, you did something wrong in your steps, or two, this wasn't actually an arithmetic sequence, right? Because this is the arithmetic sequence formula. I can only apply it if it's an arithmetic sequence. Does that make sense? So, but this should always be a whole number. Well, now I know that I'm finding the 25th sum, okay? And then we're just plugging in. So 25 times 12 plus 180 divided by 2, right? So just plugging into that S sub n one from the previous page. So we get 192 divided by 2 times 25. So what do we get? 2,400. Sounds good. And that would be our answer. Look at one last one for today. Okay, so this says find the sum of the arithmetic series. So again, I'm looking for the sum, and it's going to equal S sub n equals n times a sub 1 plus a sub n divided by 2. Okay. But what's nice this time is, I mean, you can go through all the little stuff that we did in the last one to find out our n, or we can also just use some, like, thinking power. What type of numbers are these? They're the even numbers, yeah? If I'm starting at 2, and I'm going every 2, right, because they're all the even numbers, how many numbers will it take me to get to 100? 50, right? So, like, we can just do that, just thinking. So we know that this will be the 50th sum. So we have 50 times 2 plus 100 divided by 2. So you get 102 divided by 2, or 51 times 50. So what do we get? 2,550. That's good. Now, notice like another way that I could have asked you this would have been to like say find the sum of the first 50 even numbers, right? Does that make sense? Because then we should know, oh, even numbers means I'm adding 2 each time. The first one's going to be 2. The last one's going to be 100, right? Because you'll see one that's like that in your homework. I think it's like the odd numbers though, but it'll work very similarly. Alrighty, that's all we have for today.